Hi everyone and welcome to this webinar. Last time we talked about demand forecasting process, and today we will talk about manufacturing and more specifically how you can improve your product quality within manufacturing with AI technology. If you missed the first one, it's available on our website. You can use this tool that you're watching this webinar with to post questions, and we will have a team back end here that will answer them during this session today. Welcome everyone. So let's start by presenting my colleagues that will attend this webinar, starting here in the studio in Stockholm with Magnus. And then we have participants from two places in the world. We have Naga from India and we have Michael from US. I would like to start with you, Magnus, and ask you some questions. You've been working now for Columbus for a while as a strategy consultant, and before you have worked quite many years at Microsoft with international customers. Mm-hmm. So what's your experience how manufacturing companies can use AI technology?
I think there is many different ways they can use AI technology. Of course, it all starts with understanding and having some quality in the data that you want to forward into some kind of new benefit. But then there is potential within the sales space. There's potential within the internal operations, which is sort of the case we're talking about today. And also, venturing into new areas, finding new services or new revenue streams even.
Mm. And maybe this is a tricky question to answer, but if you look at companies you've been meeting, how do you see the knowledge out there is about these opportunities that AI can give them?
I think it's a bit different, actually, varying, I would say. In some companies, there is a natural curiosity, I'd like to call it, and they are very interested in understanding and experimenting. Others are more linear. They're more just wanting to get the job done, and there it's a lot harder, even though their potential might be a lot bigger than for the exploring type companies. So it's very different. Of course, a lot of the companies are using AI in different areas of in a large corporation. But having a strategy and having something coherent, that's a few more steps along the way before that's going to happen, I think, in most companies.
But for people joining in this webinar, representing companies maybe that really hasn't started yet using this, what's your advice how to start, basically?
I think starting this is of course, feeding this curiosity a bit, trying to understand what AI or advanced analytics can do for you. We do a lot of education where we just talk about different technologies, talk about different use cases, how it can drive your sales, how it can improve your operations, how you can tap into new revenue streams based on these kind of technologies. But it has to start with some kind of basic understanding, but also a very sound business drive in terms of wanting to benefit from the technology. It's not just technology for the sake of technology.
Thank you. So in this webinar, we would like to present by real life example. And today we will use a company in the US and a project we have done for them. And Michael, maybe you can tell me a little bit about what kind of company are we looking at? What's the use case?
Sure. Thank you, Per. So this company was actually referred to us by another manufacturer in the same industry, and they have had consistent issues with quality on their production lines. The way they measure this is by looking at the breaks that they have at the end of the line, and they wanted to try to improve that rate of breakage so that they could identify and then engineer out in their process all of those breaks and make that production line flow a lot more consistently. This is a very large operation, has a lot of raw materials that get mixed in. They flow down and they get heated to very high temperatures. And the information that Naga is going to describe to you is taking a lot of that data from those temperature sensors, those IoT sensors, and then trying to make predictions around that and classify that information so that the engineers could do their jobs.
And maybe you can talk a little bit also, Michael, about what kind of value the customer got from this solution.
Sure. So there were a couple of different things that they were able to do with this information. The first was they were able to tweak their temperatures that they were heating the raw materials up at and keep it within an acceptable range. They had already done a really good job of managing those temperatures within a certain range, but this information that we were able to provide to them was able to then fine-tune that even further. And the second thing is they were able to classify and see if there were interactions between certain areas of the production line in order to also then create a better engineering strategy with how to handle the raw materials as it was coming through the line.
Thank you, Michael, for that. And I think now it will be very interesting to hand over to Naga to hear a little bit more about the details about this case.
Thank you, Per and Mike. Understanding how the manufacturing unit's day-to-day business operations and production process works is necessary before moving on. Process depicted in this slide from left to right. Raw components or materials are originally dumped into bins before being transported to furnace and melted into liquid glass. Using 8 legs, 4 on either side of north and south, the entire process is carried out in 15 separate zones. Each leg, mainly are the production outlets, contributes to the glass making process. Using many sensors in each zone to continuously collect the essential data, which includes temperature, air pressure, air combustion, and other parameters. So when we say continuously collection of the data, that means the frequency of the data is per hour. So now this entire viewpoint helped us to comprehend their daily activities and their data collection process in various phases or zones, which provided inputs to read the data appropriately. Manufacturing units may not be utilizing all the vast amount of the data they have collected in various data sources. Now we have understood the process flow and the data gathering process. Now, these are the data sources or the manufacturing stages where the data has been collected. Taking this data and aggregating at a timestamp and fusing it with the breakage report will be the entire data set that will be used further. And the power and water outage during the 3-week time period was admitted by the business to have happened. And as a result of these outrages, multiple sensors were found to be malfunctioning simultaneously. Rendering data from this particular time period is unnecessary, and so those were excluded or discarded. Data quality assessment is being done to determine the duplicates at a record level and also at a variable level in the different data sources, and the missing value are identified. Why these are required? Because these will be useful in having the smooth and reliable forecast. And all these manipulations of the data has been done using statistical approaches. Now, while preparing the data, we have found some of the challenges. Dynamic patterns has been seen or observed while preparing the data, which represents that there are data challenges. As an illustration, if you can see at the top of the slide, there are 4 sensors for which the data has been taken for the last 3 years. So the blue line represents the distribution in the last 1 month, and the orange line represents the distribution in the last in the remaining data, where I said the data is about 3 years. So you can see that there is vast difference in the distribution, and this demonstrates that the sensors are behaving dynamically. Apart from that, the correlation, the interdependency of the sensors has been identified. Again, this has been done to see whether any sensor is malfunctioning, and then it's subsequently affecting the other sensors or not. For example, here air combustion flow in zone 13, this particular example where air combustion flow in zone 13 is having a direct correlation with the air combustion proportion in zone 14. So in order to have the smooth and reliable predictions, either one of the data points will be considered further, other will be discarded. These challenges or the data preparation has been done using the sensors data. Now, on the breakage report, we have done the initial exploratory data analysis and also the visualization, which derived out various factors that are not only the sensors data, other factors that are impacting for the glass breakage. For example, if you see or hear, each day of every month, the analysis has been done at the day level, and towards the end of every month, say from 27th to the 30th or 31st of every month, there is high rate of breakage when compared to the overall breakage. And the business also talked about this particular scenario where they said that at the end of every month, some supply chain activities will be carried out. And this shows that we have not only, as I said, not only the sensors data, we have the other external parameters that are impacting the glass breakage. So to further explain, or to the last example, we further drill down to the granular level by taking the breakage report to a granular level, say at a day level, and found that on Wednesdays and Thursdays, there are more breakages when compared to the other weekdays or other days in the week. While adopting advanced analytics, we can pull insightable information from the data that which business can use to act or to do the corrective actions. So we have seen the insights from the breakage report, and also how the sensors data has been, how the distribution in the sensors data. Now, the correlation, the interdependency we have seen between the sensors data. Now, this correlation matrix is between the sensors data and that of our target variable, which is the average breakage. So here, when we say that how the sensor is considerably impacting on the breakage. For suppose we can see over here from zone 3 UG2 sensor, which is negatively impacting when this particular sensor malfunctioned, there is a negatively impact on the breakage. Simultaneously, when we have a malfunction in the delta zone 6 TNM sensor, then we have around 32% of positively impact on the breakage. So this particular analysis, or this will yield or emerges in more insightful, which can be useful in building the machine learning. So right now we have seen all the analysis, all the exploratory data analysis and everything. We will see now how the machine learning algorithm or machine learning model will tackle this particular problem. So as we have seen the data from the furnace and the other data sources and the breakage data, these has been integrated and prepared the data has been wrangled, and the clean data set has been prepared. And we also seen that from these data, the insights that were pulled out will be useful or will be implemented when there is an issue, that the businesses cannot act proactively. If business want to know which are the key influences that are impacting the glass breakage, that for that to address it, the artificial intelligence or the machine learning model is required. Now, once this data has been passed through this particular stage, the historical data, what we have had about 3 years of data, the historical data has been prepared and thus passed through this, and the machine learning algorithm has yield out or predicted the key indicators that are influencing or the impacting the breakage, and also found predicted what is the average breakage per hour. So with this information, the business can monitor these key sensors and identify and act upon them when before being malfunctioned or before impacting the breakage. So this will, as I said, the businesses can have the corrective actions, and which will reduce the downtime. And once the downtime reduced in the production hours, this will increase the production output and also decrease the maintenance cost. Here, in this particular scenario, we have done several iterations in constructing the model using multilinear regression to the ensembling models to identify the best or the champion AI model that will predict accurate breakage per hour and also the key indicators that are influencing the breakage. And to make the business understand or utilize this particular output from the machine learning, the entire output has been integrated in a Power BI dashboard or Power BI reports, where the business can see what is the actual versus predicted breakages per hour, and also can drill down to a particular time period in a given day, and also identify which are the key indicators that are influencing the breakage. For suppose we have found that the Zone 5 POS sensor is mostly impacting the breakage, and by others follow. Apart from this, we also identified what is the likelihood or the probability that a particular breakage can happen in a given hour. So these are the output that were yielded out from the machine learning algorithm, and this can be useful across different industries, not only the manufacturing. The model, or if we have the appropriate data with the right data and an appropriate AI/ML, the business challenges can be addressed across manufacturing or retail or food and beverages or in any industries. That's it from my end. Over to you, Per.
Thank you, Naga. That was a really interesting presentation, and time flies and we are soon to wrap this up. But before we do that, Magnus, any final thoughts listening to these presentations?
No, I think it was a really, really good presentation, Naga. And I think what's interesting here is that even though there's a lot of work, the business case is sort of proven. It's worth to take the next step. You're getting some value back already in this phase, but of course there is more value to uncover as we progress to later phases in this engagement.
Thank you. So by that, we will wrap this up. Thank you very much, Magnus.
Thank you.
Thank you, Naga. Thank you, Michael, and especially thank you to the audience. and I hope this was valuable for you. For you that hasn't got your question answered yet, they will soon come. And this will be recorded, as mentioned before, so you will be able to download it from our website.